Hi, everyone. So this was my original title that I submitted to HashiCorp, autoconfigure your vault and boundary with CTS. But when I started working on it, it kind of felt that it's missing a soul. So same story, hopefully better title, how to make your DB and security love you. Now, I assume you already saw a lot of boundary, and you know Vault, so I won't deep dive into that. But other than this, let's start. During my talk today, 2 to 3 DBAs are going to quit their job. And not because of me, but because someone, for the 4th time this week, asked them to create new username and password for a new microservice. Another fact. 0 out of 4 security engineers actually enjoy creating access to new microservice endpoints, right? Doing least privilege to microservices that created weekly is hard. And I want to tell you it doesn't have to be this way. I will show you a demo, and I will share with you a code that actually show you how you can have automated self-service with clear roles and responsibilities. So quickly about me, I'm Lev. For the last 5 years, I've been working as CTO at TerraSky. I've been doing Linux sysadmin since 2000. I'm Hashi User Group Israel and DevOps Days TLV co-organizer. For the last 2 years, I've been part of HashiCorp Ambassador program. And when I'm not stressed on stage, I actually enjoy building weird mechanical keyboards, as you see on this image. So if you're into that, please talk to me after the session. All right, let's, with the raise of the hand, understand kind of who we have in the audience. Do we have any developers? OK. Do we have anyone from operations teams? OK, cool. Do we have any DBAs? Not enough. This is why DBA don't like you, right? Because you don't bring them to the conferences. So do we have anyone from security team? OK. Do we have any DevOps engineers? I'm sorry, DevOps is still not a job, it's a culture, so I'm sorry about that. But anyway, I hope that it will be relevant for all of you, my talk, because it just covered different angles of the self-service. So quickly about TerraSky, we're system integrators. Whether you want to have Consul or Vault deployed, Kubernetes on-premise or migrate to the cloud, we've got our customers back. And we're actually HashiCorp Partner of the Year for EMEA, and we're super proud and happy about it. Yes. So let me tell you quickly 2 stories about our customers. One of them is a huge gaming company, and they use Vault, and they use static codes. And they told me that they created a controller for Kubernetes that every time an application deployed, this controller actually creates username and password statically and places it in Vault. And this story kind of sat with me for a year about, until I was recently talking to another customer of ours that uses Vault and actually have dynamic secrets. And they told me that every time they deploy a new database, they still have to go and configure remote access from Vault to the database, dynamic secrets, dynamic roles, and all of those things. And I said, OK, it's actually those 2 cases are not different. They're the same. It's event-driven configuration of Vault, right? And I don't know how many of you here are familiar with Consul Terraform Sync, but this is actually a great solution in HashiCorp to address that problem. So how many here tried CTS? OK, great. So let me tell you about CTS. CTS is Consul Terraform Sync. The first part is Consul. And Consul, as you know, does a bunch of stuff. It does service mesh, key value. For our case, most important is service discovery. And specifically, there's a feature called catalog sync that syncs all the services from Kubernetes to Consul and back. Second part of Consul Terraform Sync is Terraform. Everybody here probably know what Terraform is. It's infrastructure as code. It's declarative. It's state-aware and idempotent. And my favorite, it knows dependencies. So I don't have to write things in specific order. Terraform can figure it out. Here's a bunch of examples of Terraform provider that are not public cloud infrastructure. And I really love to show that it can do more than AWS instances, right? You can deploy to Kubernetes. You can configure alerts in PagerDuty or have Grafana graphs. So this is what the CTS actually is. The first kind of square is our service, right? It can do horizontal auto-scaling. It can go up or down. Consul, because it's a service discovery, will see those changes. Now, Consul catalog sync will take those changes from Consul and create a variable file, a Terraform TFRs file, which it will provide to any module that you want of Terraform. So, for example, if we have auto-scaling and there's a new instance, Terraform will configure a firewall to access this instance. This is the idea. And this is how Consul Terraform Sync is actually marketed, right? It's called Consul Terraform Sync, but it's marketed as network infrastructure automation. And most of the blogs you will find talk about F5 and Cisco load balancer and stuff like this. And I actually want to rebrand it into completely terrific solution because I think it can do much more stuff. And I actually did a talk on this that talks not about on-premise solution, right? I showed in this Consul Terraform Sync awesome use cases how you can configure Boundary, how you can configure Prisma Cloud, for example. And since then, I actually had another idea that has nothing to do at all with networking or firewalls. How many of you know that there's a Domino's pizza provider for Terraform? Yeah. So you can automate your CTS. If the microservice is down, we can order 2 pizzas for our microservice team, because maybe there's a long night waiting for them. All right. So let's talk about the problem that I'm trying to solve. We have dynamic secrets, and they're great, and we love them. But every time there's a new database or new application, I still need to go and configure in my Vault, remote connection, the dynamic role, authentication role, right? There's a lot of stuff. ACL policies. So this part is still manual, even though dynamic is awesome. Second thing is we hate VPN, and we love zero trust. And HashiCorp introduced Boundary, so this is great. And Boundary even supports Terraform, so it's even better. But still, every time there's a new microservice, someone actually has to go and configure this microservice in Boundary. Like it will have an endpoint, so still manual work. And you're probably saying to yourself, well, it's Terraform, right? I can write my own Terraform. I don't need any CTS. I can have it in one single file with data sources and providers and everything. But this is not a self-service. You're not going to McDonald's and flipping your own burgers, right? We barely clean after ourselves. This is the experience, right? I want to deploy database, have Vault and Boundary automated. I want to deploy an application and Vault and Boundary automated. So the challenge, what I'm trying to solve is clear? Yeah? OK, cool. So from now, it's going to escalate quickly, so bear with me. We're starting with a lot of arrows and a diagram. This is the demo that I'm going to show you. Some of the things are like set up before. So I already have AWS VPC with EKS deployed. I have HCP, Vault, and Consul because it's super easy to just deploy it securely. Then I have VPC peering between my VPC and HCP for secure communication. And I have catalog sync, CTS, and Boundary deployed inside of my Kubernetes. Okay? At this point, this is where we will start our demo. I will first deploy Postgres, and catalog sync will actually see a service in Kubernetes, and it will sync it to Consul. This will trigger CTS, right? Because CTS will say, oh, there's a new service. Let's do something about it. It will connect to Vault, and it will configure, first of all, the new DB mount and the connection to Vault. And it will create a support role. So I have an idea that every database needs to be supported, and I just created some statement query that will create a support role. After that, Consul will connect to Boundary and actually configure a target. So our support guys will be able to connect to the Postgres. And then I will show you the developer flow, right? So developer will just come and deploy some application, right? And again, catalog sync will see it. It will sync it from Kubernetes to Consul. It will trigger CTS. And CTS will connect to Vault. This time, CTS will configure dynamic role for our application to access database. And then it will connect to boundary and configure boundary target, so our users will be able to test their microservice. And from then, I will show you that from my laptop, I can actually connect to my software and to Postgres. A lot of arrows. I hope you're with me. We're going to talk about Treehouse, how it looks, how it works, and how to make it secured. I personally think that how to make it secured is the most critical, but we will start with how it looks. So I have a recorded demo because there's race condition, and sometimes it takes 10 seconds, and sometimes it takes 2 minutes or 5, so we can't wait. This is why it's recorded. OK, so I have a couple of tabs open. I have my Consul, I have my Vault, and I have my boundary. Okay? And in Consul, you can see that we have 2 services, our boundary service and our Consul service. In Vault, we have 2 secret engines, cubbyhole and key value. In authentication method in Kubernetes, we have no roles at all. Okay? And we have some default policies, so boundary can connect to Vault. That's all we have. In boundary, I'm authenticated as Jeff, who is kind of an admin, and he has 2 scopes, dev access and DBA support. Now, in dev access, we currently have no targets. It's empty. And in DBA support, we have 2 targets. Redis and Postgres, they are part of boundary itself. So I'm running demo magic of how it looks. And I first will print some stuff, deploy a database, and explain the stuff that I've printed. OK, so I'm using Helm chart to deploy my database. And specifically from Bitnami, I will explain why. But basically, I'm waiting until everything is ready. This is the chart I'm using. And I'm setting the primary service type to be load balancer to make things easier. Now, in our Kubernetes, we have boundary running. We have CTS that will do all the magic, and I will show how. We have Postgres and Redis, again, part of boundary itself. We have our Consul client running as daemon set that are connecting to Consul HCP. We have connect inject that does nothing. It's just service mesh. We're not using service mesh in our case. Consul catalog sync that does the syncing stuff. And Vault agent injector that will put secrets in our pod. OK. So our deployment is finished at this point. Let's go over the services quickly. So we have boundary controller. This is our only external load balancer at the moment. And this is Consul. As you can see, it's external name. This is because it was synced from Consul to Kubernetes by catalog sync. And the rest are just cluster IPs. So this is the reason I want to show you why I'm using Bitnami, because of the password that is stored in Kubernetes secret. We will use it later in Terraform to configure our Vault. OK, so let's see if our database is running. So as you can see, this is DB1, Postgres 0. We have our database running, and we have 2 services for this database, the actual external load balancer that we will use, and the headless server. We will ignore it just to make things simpler for the demo. OK, let's see what changed. Back to Consul. In Consul, we have a new service, right? We have DB1 Postgres. If we click on an instance, you can actually see it was registered from Kubernetes. This is the catalog magic. And we have the ELB address. Very convenient. This actually configured the Vault. Let's see. You see in secret, we now have new mount of our database automatically. And it's empty. And this is the race condition I've mentioned before, right? Nothing in connection, nothing in roles. It takes a while. And then, boom, it got configured. I will explain later how I solved this race condition. But basically, it takes time until ELB is propagated, ELB DNS is propagated, and until it's actually available. It took a while to figure out. But then we actually have everything, right? And now we have our connection. This is our connection of DB1 Postgres default. If we click on it, you will actually see that it connects Postgres with this username, with the password that you don't see, with the actual ELB address, and with the port that we pulled dynamically. The other thing that we have is a role. And this is a support role that I told you. And I guess it's a bad support role, but it creates username and password and grants select on all tables to schema public. I assume your support do something more sophisticated. And this is our boundary. So this is the cool part, right? I go into DBA, and in targets, I have a new target now. This is my database target. But this is my favorite part, the credential sources, right? This what will go to Vault and actually pull it from the path that you just saw that was just created a second ago. And this is why Terraform is awesome, because it understands dependencies, so everything will be created automatically. Think about hours that you saved. OK, now I'm a developer, and I want to deploy my application. This is my service YAML, right? Simple Kubernetes service, nothing special. The whole logic is hidden here in labels. I'm asking access to this database, access to PG user table, right? PG catalog schema. This is what I'm asking access to as a developer. I'm creating my service account, and then I have my deployment. Again, just a regular Kubernetes deployment with Vault annotation. I'm asking to inject a Vault agent. I'm going to create a check file with this secret, and I'm going to generate that content. This is the Vault template, right? And I'm just doing PSQL command that will connect to the database with username and password, and it will select star from PG catalog PG users. We're just querying for all the users in Postgres. Now, I was lazy. I told you this is a microservice, but it's just Bitnami Postgres container for this PSQL binary. But I want to show you that it's also web, so I'm downloading in the command Caddy web server. I'm sorry I was lazy, and it's not a real microservice, but it has a web server, and it will have our PSQL command. So let's deploy this thing. So I'm doing kubectl apply, and this thing created a service account, and a deployment. Again, nothing fancy, no CRDs. First of all, you can see that this is our database, and this is our deployment, and it's stuck in init. And there's a reason for it. There's a race condition there that is elegantly solved. And this is our service app sample. It should trigger CTS to configure all the magic for our application. Let's wait for the container to become ready. And you see it's not immediately ready. And the reason, because there's a Vault init container that tries to connect to Vault, but there's no authentication method. It doesn't exist yet until CTS was triggered, configured. And because Vault init was retrying, at some point, you will see in a second, it actually has a Vault authentication role available, so it's successfully logged in, and everything is continued. So like, there's a race condition that's solved by having Vault agent trying again and again. And now in our console, you can actually see this is our service. And in our Vault, you can actually see that in our database, we have two roles now, right? And we have our app sample role, which actually gives us select, insert, and stuff on Postgres catalog.pg user that we asked in the labels, right? This is great, in my opinion. Then in auth methods, we actually created our authentication for our service account. And this is my favorite part. There's an app sample. So I don't know if you see it, but this is actually a least privileged access, so you can be lazy and secured with CTS. OK, this is our boundary. In our boundary now, we have a target of our app sample default, so we can actually connect to it. So first, let's see if the permission working. But this is Vault. It's definitely working. This is our check file. It generated the content that we wanted. And if I will just run it, it will pull the users from the database for me. Great. So simple Vault agent. Now I'm connecting to boundary itself. This is boundary in action, and I really like it. It's relatively simple, but it's really nice. I'm authenticating as Jeff, and the password is foo. And after I connected, I'm doing boundary connect HTTP, specifying target name, specifying target scope, and saying that it's going to be HTTP. And I got response for my web server. This is the Caddy web server response. This is the cool part. Boundary connect Postgres, right? I'm just specifying database name, target, and scope, but there's no username and password at all. And boom, I've landed inside of Postgres. And these are the databases. So I personally think this is like really magical to actually see it working. So let's see how it works. So I'm running the demo magic of how it works. And first, let's see the structure of my repository. So if you will try it, you will have a sense. First, set everything up. How it looks is the automation that you just saw, and how it works is this one. So those are Terraform modules that are doing the configuration. This is this one for app, and this one for database. AWS obviously sets up EKS and VPC and all of those things. Boundary part I just took from repository of boundary reference, right? It just deploys it in Kubernetes. And this is my HCP. It configures Consul and Vault in HCP. All right. Boundary is structured in two parts. The Kubernetes part that deploys stuff inside of my Kubernetes, right? And the boundary that creates scopes, users, and default stuff. I quickly want to show you the changes that I did in this repo, just to kind of make it work. So first one is this. It's the image of boundary that is just latest image. Second one is the config. The repository assume I'm running in Minikube, so I had to change the local host to some real FQDN. And instead of localhost, just a second. And the last part is the scopes. So I created DBA and Dev Access scope. OK. This is the important part, the CTS HCL. So we have Consul, because CTS needs to connect to Consul. So this is our URL and our token. And then we have the task part. And this is the core of CTS. This is how it works. So we have a task stanza that says a condition is services. And every time there's a change in a service that matches this regular expression, let's say Postgres, let's run the Terraform module that placed here. Okay, this is how it works. You just say, this is the condition with this regular expression for app. Let's run the module, the Terraform module for app configuration. Okay? Then I just saying that I'm going to run Terraform locally. Those are my providers, the location and their version, and you want to be explicit in those. And then I just configure my providers. And as you see, it's horrible. It's plain text, but we will address it in a second. So I have my Vault provider, right, with all the tokens. And I have my boundary provider. And I have my Kubernetes provider, which is empty, because Terraform provider is smart, and it can use JWT token of the pod, which is very nice, in my opinion. This is how I deploy the CTS inside of Kubernetes. It's just a pod. And this is the image. It doesn't have to be enterprise. There's a container for open source as well. This is the file that you saw. And I just took all the files and directories, placed them in secret, and just mounted them in pod. The only special thing here is this service account CTS, because I need a privilege to query my secret and my services. That's the only special thing. All right. So when I run my pod, inside of the directory, sync tasks folder created with all the task names inside of it. Okay? And in there, you will see all the files that are auto-generated by CTS. And for our case, the most important is the Terraform TF vars, because it actually contains the changes, right? So you will get a map of services. And each object will actually have those attributes of name, address, and it's almost everything that we need. Almost. I will show you when it doesn't have everything. So let's see the code, now that you saw the input. All right. So first, let's see how I configure the database. So I told you there are two services in database, and I'm just filtering out the headless services. I'm ignoring them intentionally. Then I'm creating a mount, and I can't continue. I need to wait, because there's a race condition, and everyone loves race conditions. So I need to wait until DNS from ELB propagated. So what I'm doing here is, you see, I'm doing until netcut is successful. That means the DNS propagated and database responded. And this is a null resource called wait for ELB. I will wait for it. Then I just pull a secret from Kubernetes. This is our Postgres secret. And I'm creating my connection, right? So this is our connection that is waiting for our DNS. And I'm just using Postgres, the password that I pulled, the address, and the port. OK, and I'm just creating our support role. OK, this is just a support role that you saw before. OK, let's see the application. It's pretty much the same logic, but it's a bit different. This time, I'm taking our application, but I don't have enough info there. I need the labels, right? So I'm doing data source for the labels for each application that I found, and then I'm just creating a map for only labels. From there, it's pretty much what you saw before. This is our making DBA love you section, right? Because I'm taking stuff from labels and just creating this statement that says, grant me those actions on this schema that I pulled from label and on this table that I pulled from label. I'm creating my ACL, and I'm creating my authentication role. This is on a high level and super fast how it works. But I think that at this point, some of you got triggered, right? Because I allowed my developers actually pull stuff in labels. So you have to validate your inputs. And this is cool, because now in Terraform 1.2, I have precondition that I can use for validation, right? I can actually check if I have any special characters or if it's in a valid list of databases. If you're enterprise, you probably should use Terraform Cloud with proper Sentinel and proper approvals. But if you're just an open source user, you can definitely hack it this way. The other thing is RBAC, right? Every time you deploy a service, now it can get you access to all kinds of stuff. So make sure it's restricted as much as possible. VCS repository, same. If you work as GitOps, make sure it's as least privileged as possible. And Terraform providers, right, don't have one task that solves all the problem in the world. Now, I showed you that there's a sensitive data, and it can actually be pulled from Vault, which I think is awesome. All you have to provide is this stanza for Vault. But there's a Vault token appears, right? So we're still in that challenge. And HashiCorp solved it so elegantly. I really love it. They actually give you Vault agent token that you can write as a sidecar container that will do auto-authentication, and then you can just use the file for token to do all the rest with CTS. So let's quickly summarize. Most of you already facing this issue, right? Have some compassion for a DBA security team. Most of them are good people. And CTS can actually help you solve those challenges, right? So this is the QR code. If you have any questions, I will be available. I actually have this environment running, so please come to me and talk to me if you want to understand better how it works. Thanks a lot.